To understand what happened in the very early universe, we need to understand a little bit more about physics. So there are four fundamental forces. What that means is there are four ways that we know of that things interact with other things. These are gravity, electromagnetism, the nuclear weak, and the nuclear strong forces. Here is our first lecture quiz question. What does gravity act on? A, mass, B, charge, C, velocity, or D, momentum? Go ahead and think about it and we'll discuss in just a bit. So what does gravity act on? The answer is A, mass. Gravity always pulls mass together. So gravity acts on mass and is always attractive. It's always pulling matter together. Now this is actually the weakest of all of the forces. I realize that sounds really, really weird, but I'll discuss it a little bit more in just a bit. Another one of the forces that we've touched on a little bit is the electromagnetic force. This acts on charge. Now, if you remember, there are two types of charge. There's positive and negative. Positive and positive repel, positive and negative attract, and negative repel. So the electromagnetic force is both attractive and repulsive, and it is significantly stronger than the pull of gravity. As an example, think about your weight. So if you remember way back, we actually defined weight in two ways. In this case, I mean the pull of gravity on you. So gravity is pulling on you, and that force of gravity is your mass and the mass of the entire Earth. That's what's giving you your weight. You and the Earth together give you your weight. But you do not just fall through the Earth because of gravity. We have the ground, or a floor, that's in between us, that is supporting us. That support force is actually the electromagnetic force. You've got electrons in the bottoms of your feet, and there are electrons in the top of the ground, and those two sets of electrons repel each other. That repulsion is why you don't fall through the Earth. Now, think about how big your foot is. Hey, your foot isn't that big. And yet, the repulsion from just your foot is enough to counteract the pull of gravity from the whole entire Earth. That's what I mean by gravity is super weak. Okay, so one of the forces that we've never really touched on is the weak nuclear force. This acts on the things that make up protons and neutrons. Protons and neutrons are not fundamental. What that means is they're not the smallest piece, they're made up of smaller things. We call these things quarks. Each proton and neutron are made up of 3 quarks. The weak nuclear force acts on tiny particles called neutrinos. If you remember back when we talked about the sun, we talked about neutrinos. They also act on electrons. Now, it works only over very short distances. That's why we refer to it as a nuclear force. It acts on the things that make up the nucleus, and it's also very short range, about the size of a nucleus. Once you've separated the particles by more than the width of a nucleus, this force doesn't do anything. So it only acts over a very short distance. The other force that we haven't really talked about is the strong nuclear force. This also acts on quarks, and it's what's responsible for holding the nucleus together. Remember, the nucleus is made up of protons and neutrons, and those protons are positively charged, which means they want to repel. And because of how close they are together, remember the nucleus is super, super tiny, they really, really want to repel. So there has to be some other force that's holding those together. That's the strong nuclear force. It is what's responsible for holding the nucleus together, and it acts on protons and neutrons, or more particularly, the quarks that make up protons and neutrons. Now, this is also a very short-range force. Once you separate those protons by more than the width of a nucleus, then their repulsion takes over and they fly away from each other. This is the strongest of all of the known forces. As physicists have been studying these forces, they do experiments at higher and higher energies to see how it is that these forces behave under higher energy, meaning higher and higher temperature. Well, something that they have found is that the electromagnetic force, remember that's the thing that acts on charge, and the weak nuclear force, that's the really short-range force that acts on the quarks and the neutrinos, Once you get to a high enough temperature and energy, they unify, meaning they become identical. There's no way to tell which force is causing the interaction. They start doing the exact same thing. Now, this unification of the electromagnetic and the weak nuclear force we refer to as the electroweak force. The electroweak force. The fact that we see the electromagnetic and the weak nuclear forces unify at high enough temperature has led some people to suggest that maybe at even higher temperature, the strong nuclear force will actually unify. So, theoretical physicists trying to explain these things have created what are known as grand unified theories. These are the theoretical, mathematical things that are trying to unify all three of these forces into one grand unified force. Well, this idea has then led other people to suggest, well, maybe we can get gravity to be included into this. So these theories that try to unify all four forces into one single force are known as theories of everything. Now, the problem with theories of everything is that you have to unify quantum mechanics, which deals with the probabilities and the uncertainties dealing with the very, very smallest things in the universe, with general relativity that describes gravity on the biggest scales. And these two theories do not play nicely together. Every time people try to put them together, we get things blowing up to infinity all the time, all over the place. And that's absolutely not actually happening in reality. Now, there are several attempts to create one of these theories of everything. If you've heard of string theory, this is one approach. Another one is loop quantum gravity, and there are several others.